So let's take a look at the data that we have here. So if we're going to calculate the linear correlation coefficient, R, so how strong is the positive relationship between the alcohol content and the number of calories in a 12-ounce beer? So to determine if there's a positive linear correlation, a random sample was taken of beers, alcohol content, and calories for several different beers. And the data are in the table below, and we're asked to find the correlation coefficient and interpret its value. So remember, this is a data set that we started with back in the beginning of Chapter 10, but it's without the outliers. So we took out the non-alcoholic beer called O'Doul's when we were continuing with this through the rest of this chapter. So again, in our solution, if we state our random variables, so X in this case was the alcohol content in the randomly selected beer, and Y is counting the number of calories in that same randomly selected 12-ounce beer. So again, we have two measurements, two different quantitative variables on the same object. Okay, so we've got a linear regression test, or linear regression problem. So the assumptions that we need to check here, we need to have a random sample. So if we go back up to the problem states that a random sample of beers was taken. Random sample of 9, in this case, beers was taken. And the second condition, if we go back and look at the scatter plot, let's get these little markings off there, I don't know where those came from. So if we're looking at our scatter plot here, it did look roughly linear and we don't really have any outliers. So the scatter plot of the data is roughly linear with no outliers. So again, remember, it did kind of have one, but we took it out, and we didn't take it out simply because it was an outlier. We took it out because it made sense to do so, because we had a non-alcoholic beer thrown in the mix of all these highly alcoholic beers. So we threw it out based on that, and then our graph looked better. We have here, we also have the value of R. But again, if you notice, all of these, the beginning letter here is capitalized on here. For linear regression, we're going to use a lowercase r there. So R in either case is about 0.913. So again, a number between -1 and 1 inclusive and unitless, so it gets no units. So this is really close to 1. So it looks like there is a strong positive linear correlation between alcohol content and number of calories for beer.